Morning. So thank you for letting me come in and address you this morning about, well, we'll eventually get to sensors and edge computing, but I wanted to spend a few minutes sharing with you kind of Intel's approach to some of the big challenges that we talked about this morning. And I'll start with the area around sustainability and the energy transition. So my name is Mike Bates. I'm the general manager for Intel's energy vertical. I'm on the sales and marketing side of our company, and I also lead our newly formed Center of Excellence on Energy. And I am an energy guy. I've been in the quote-unquote energy industry pretty much my whole career. Literally, I went to school at Texas A&M University, and I started my career working in the oil fields around College Station. And then moved into the oilfield services industry immediately after that. So I could say I spent the first half of my career literally with my own hands unlocking a lot of carbon. The second half of my career, which has been pretty much the last, say, 15 to 20 years, has been spent on the energy transition in the electric utility industry, and primarily solutions and technologies that address carbon footprint and greenhouse gases. So you can say that the second half of my career has been really removing some of the damage of the carbon maybe I unlocked in the first half of my career. But anyway, I know we're going to talk about sensors and edge compute, which is an important topic. But I'd like to just spend a couple of minutes to make sure my clicker works, putting a little bit of context around, why sensors and edge compute, where sensors and edge compute, even how to deploy sensors and edge compute around some of the new business models that we're starting to see emerge in this space. And I'm going to use sustainability and energy sustainability, the challenge in both of those areas, as the context around my comments around sensors and edge compute. So Intel, and I actually get this question a lot when I'm sitting in front of a utility or an oil and gas company. They're like, why are you in the room? I mean, maybe that would happen 2 or 3 years ago, but today I think folks are starting to better understand what Intel's role is in this transition, this energy transition from carbon-based energy to something more renewable, green, and distributed. And one of the ways that I can position Intel and our technology is around something we call our RISE initiative. RISE stands for Responsible, Inclusive, Sustainable, and Enabling. And I've been at Intel for 7 years, and one thing I have learned at Intel is that they're one of the best acronym-producing companies I've ever met with. So we created a really broad sustainability strategy around a 4-letter acronym. I'm going to talk mostly about the sustainable and enabling components of our sustainability strategy, but I can't go there without mentioning the R and the I. I think Intel feels literally responsible for applying some of its great technology, and even more importantly, our ecosystem, to solve some of the big challenges that we face as a planet. And of course, energy sustainability is one of those. We talked a little bit about it this morning with some of the geopolitical things happening in Europe. We also talked a little bit about some of the climate impact changes that are impacting our ability. I mean, I live here in Texas. I don't know how many of the folks in the room live here in Texas. I've been here pretty much my whole life. I was here a year and a half ago when we had the winter storm, which I guess has a name now, Uri. And I know, from that experience that there's a lot of work that needs to happen around climate adaptation. As much as we talk about climate mitigation and lowering carbon footprint, which is an important way to apply technology, but I think another way to apply technology in this particular area is to prepare us all for the coming impacts of climate change. I know we're seeing them today, we've seen them in the years past, and whether you believe climate change is human-induced or not, and I don't want to get into that argument, I can't believe we still have it, but what I'm really wanting to talk about is how do we, regardless of why it's changing, we all, I think, can agree that climate is changing, and how can we apply technology in a way that is responsible and inclusive so that everyone gets the benefit of the application of these technologies, not just folks that can that can afford a rooftop solar or an electric vehicle. So we do see the responsibility to apply these technologies in a really inclusive way so that everyone can get the benefit for it. For example, the folks that live in and around the downtown areas in Texas. You saw the photos back when we had that event where all the downtown buildings were totally lit up and all the neighborhoods nearby were dark. The reason being was that the critical facilities like hospitals and other emergency response centers were on the same feeder as a downtown building. And I know that that technology exists to avoid that. It just has not been deployed because the industry has not had the appetite to invest in the edge, have not had the appetite to invest in the technology needed to do scalpel-like load control in the energy industry, which is the one I'm going to be talking most about, to avoid that impact. We could have easily had technology been deployed at the edge of the grid, done load control, turn off or turn down those buildings that we all saw lit up where no one could actually even get to those buildings. You couldn't even drive there. And instead divert that power through an intelligent grid back to those areas where people needed power. So again, if you think about it from a top-down perspective, it's really what Intel's role is and what my team's role is to apply this technology to some of the things happening, some of the challenges in the energy transition. And I can, I guess, confidently claim that Intel is making a big impact in this energy transition. And I say that just from the raw scale of the company I work for. The company I work for is all over this whole energy transition and all the way from the supply chain and taking carbon out of the products that our customers buy, but also taking that scale at Intel and applying it to solutions to help us all manage through this energy transition. And we're going to talk a little bit about that in a second. I'm going to get into some more details about the technology, as I know we're here to talk about sensors and edge. I just wanted to help spend a few minutes kind of giving some context about why Intel's even sitting here on the speaker panel talking about this. If you think about our own kind of cycle or circle of innovation, it really does start with the work, my work starts with the work that happens at Intel around our supply chain. So we are one of the biggest consumers, as you might imagine, of energy, water, products and supplies that come from our supply chain. So we're looking at our supply chain and really challenging our supply chain to take as much carbon out of the supply chain as possible. And it's an ongoing process. They'll probably be with us for the foreseeable future. Then we take those raw ingredients that we have done, that we've done our best job to take the carbon out, and we create products from those raw ingredients. So the starting point for the solutions that we take to market come from products that have already been through, call it the carbon washer, if you will, and the team at Intel that really looks at the supply chain. So then that's really my team's starting point. We take those products, and again, a product that might today be in a laptop, or a product today that might be in a server at a hyperscaler like a Google or a Microsoft, and we turn those raw product capabilities into solutions for this particular market and other verticals. And that is where I sit, and that's where my team sits. We're a collaboration team that works directly with end users that have and experience the problem statements that we're talking about today. So our customers today are distribution system operators, utilities that own the wires that deliver the power to your home or business. We also work very closely with, I'll call it commercial industrial customers that have a high carbon footprint problem. In a lot of cases, those customers also have a lack of expertise around sustainability and energy sustainability. So we're downstream of the substation as well, working again to lower carbon footprint. And we're also very active in the edge side as well. And I'll get into some of those examples here in the next few slides. So what you see here is I think this is the area where we're investing and we've gotten the most traction. And as again, one thing I'll quickly say before I get into the details of this solution, the reason we're in the room with the utilities that are looking to remake the grid or modernizing the grid is because they have, and anyone in this room that's familiar with this industry knows that the electric utility industry model, the delivery model, has pretty much been the same for the last 150 years. Centralized generation from a power plant someplace far away from the point of consumption, and then through a series of transmission distribution network is delivered to the point of consumption. When more consumption was needed, we just build more power plants. And I think everyone can agree the day of building more power plants, centralized power plants, coal plants, maybe we go to modular nuclear sometime in the future, but the days of building big, heavy, centralized power is moving away and maybe gone. I don't know when the last coal plant was built. I don't even know when the last coal plant permit was approved. But I think we can all agree we're moving away from that centralized model to something highly distributed through the introduction of renewables, wind, electric vehicles, which we fully expect to spike, as well as market drivers that are moving distributed energy resources closer to the point of consumption. Some of that is driven by mandates to be carbon neutral or net zero, if you will, as a company. And those companies that we work with recognize that the power coming off the grid is never going to get them to net zero. There's not enough RECs in the world to get a company to net zero. Even my own company is challenged with that. So what we see happening is those companies that are aggressively driving to net zero are deploying their own renewable energy, green renewable energy on their site. So those customers that have that on-site energy are looking for a way to integrate those loads to the grid as a way to trade excess capacity. The primary purpose for deploying them is, again, lower carbon footprint and create a more resilient energy system so that if you're in California and there's some threat for a wildfire, you don't have to go through these rolling blackouts that are happening today as we speak. My favorite story is, the ice cream maker who's got a storefront, and every time he gets a signal from the grid that, hey, you got to turn your power off, he's out of business. So how many times is this going to happen before businesses, even smaller businesses, start to deploy these new systems? So we're working with utilities that have systems in place, grid systems in place, grid management systems in place that were built for the old model. These utility customers have gone to the incumbent ecosystem and asked that ecosystem to change from closed proprietary solutions to something more open and interoperable. The need for something more open and interoperable is the need to be able to navigate this energy transition in ways that we don't foresee yet. The incumbent ecosystem has been hesitant, as you might guess, to move away from closed proprietary systems with high profit margins to something more open and interoperable. One, it commoditizes the edge. So there's a lot of profit from these companies on the edge solutions. What it also does is it moves the action to the applications and less on the actual edge itself. So what we're doing with utilities in Europe, in the US, in APJ, and these are big named utilities, is to develop through solution architectures and reference designs a new open and interoperable substation solution deployed in the substation, either secondary substation or the primary substation, that does a couple of things. First, it consolidates all the workloads at the edge in a way that allows for new insights in what's happening. And this includes distributed energy resource workloads, and it includes some of the traditional energy workloads. So a lot of that new data, as it was mentioned already about the value of that data, is creating new services and new approaches to the energy transition. So what you see here is an example of, on the I guess right-hand side of the slide is just an architecture view of what this open platform looks like. There's not a lot of detail here, but just to show you how we've built this containerized platform. And on the left is an actual example of a deployment. What you see there, I believe this is Salt River Project in Arizona. On the far left-hand slide is the substation, I'll call it of the past, which is, as you can see, and if anyone's ever been in a substation, you can see it's a bank of electrical mechanical equipment, legacy equipment that's really been in place. It's all kind of point solutions that get layered on as the utilities emerge to something that literally looks like a server, and it is a server. It's a ruggedized 61850 approved system that replaces everything you see on the left-hand side. So not only are we consolidating workloads, we're consolidating actual technology in this substation approach. So this is an area that has a lot of promise, not just for Intel, but for our ecosystem of partners, including companies like Dell, who have just released a 61850 substation compute solution, companies like VMware and Red Hat that are virtualizing these solutions, and then a whole army of companies that are creating software applications that can be plugged in and plugged out of this software platform, or of this substation platform. Another area, so this is, again, quickly, this is a slide that just shows a little bit of the focused work around grid modernization and substation modernization. These represent solutions, even though they're just a picture. They do represent solutions, as I already mentioned, through some of the bigger companies in this space that we're working with, and with some of the larger utilities in the U.S. The key utilities we're working with today in a coalition is our Southern California Edison Salt River Project, American Electric Power, Entergy, and National Grid. In Europe, we're working with Iberdrola, which is a large utility in Spain, Enedis, which is the utility that serves the country of France, EDP, which serves the country of Portugal, and National Grid in UK. And then in the APJ region, our big utility there, customers, Tenaga Nacional. So we're working with some brand name utilities that recognize the need to apply technology at the far edge of the grid to be able to optimize these low latency, time sensitive workloads in a way that makes them look and act like baseload, which is the load that we're trying to replace with these distributed energy resource loads. And I would contend that until you can make distributed energy resources deliver power in the same way baseload delivers power, you're not going to be able to replace the baseload. Seems pretty simple. The grid today is not capable, because the technology does not exist, to be able to orchestrate in real time load balancing of these highly distributed loads to make them look like baseload. So that's our ultimate goal, to flatten the grid the way we flatten the internet, to deliver the highest and best use electron regardless of where it sits, where its physical location is. So when you go back to the Uri, the Texas winter emergency, the highest and best use electron was the one to the home to keep the folks that were home and stuck at home warm and have water. So whatever system is in place would deliver that power and turn off again the power, as we just talked about in the smart building. So that's really kind of the overall goal and where we're going with our smart grid modernization solutions. As I also mentioned, we're heavily invested in the electric vehicle charging infrastructure. And I'm not talking about charging in the home. I'm not even talking about level 1 or level 2 charging, or even some of the charging stations you see here in Austin that are deployed by Austin Energy. What I'm talking about is DC fast charging. I'm talking about the 10-minute charge. So what we're doing today is working with this ecosystem to develop not just the 10-minute charge platform, but also the customer experience. So today, and I know Scott's coming from Pecan Street, we had a conversation with Scott about this a couple weeks ago. So the data we have today on the electric vehicle charging is really based on the data of the current charging technologies. And that would tell us that most of the charging is going to happen at home. You come home, you plug in, next morning you wake up, you're out. And I think Pecan Street has a wealth of data on those charging experiences. What we don't know yet is once we have a proliferation of EVs and a proliferation of EV fast charging at retail, does that change the charging experience? And the jury's still out on that. There's some big companies looking at this, like Shell and Chevron, who you would typically go to fuel your vehicle. Is that where you go again? Do you pull into a 7-Eleven and wait 10 minutes and fill up your vehicle, get a big gulp or whatever, and then you're out the door? I don't believe that's going to be the charging experience. I don't want to hang out in the 7-Eleven for 10 minutes, honestly. I even really want to hang out there for 2 minutes. But where is it going to be? So is it going to be at Starbucks? Are you going to pull in to Starbucks? There's going to be some retail experience when you pull in, say, hey, Mike, welcome back. Last time you were here, you ordered a latte. Do you want another one? Maybe there's a display there. Maybe it's a pod, and you're charging 10 minutes, but they're giving you an experience. You don't even think about charging. You're just there for the customer experience. So that's the approach we're taking. So we're combining our technology around the charging itself with customer experience technology from our retail division, as well as working with utilities to prepare for the power quality needed for these 10 to 15 minute charges. I can tell you right now, we're working with, I can't give you the name, but it's the largest motor company in the US. This company has selling an electric vehicle pickup truck. This pickup truck, the perception is, you pull this pickup truck in your garage, the lights go off. I don't know if anybody watched the Super Bowl this year. It was on the Super Bowl ad. Then you plug your vehicle into your home, and all of a sudden the lights come back on. And anyone that knows the technology here knows that power may stay on for 10 minutes from a battery in a pickup truck. What this company wants to do, of course, is to aggressively sell this product. And they want to aggressively sell it in a way that allows for the owners of these vehicles to charge outside their home and charge with a 10 to 15 minute charge. The challenge with that is you can't sell that vehicle and inundate the grid in a certain pocket because the grid is not prepared for it. So theoretically, the modern grid could slow down the sale of electric vehicles because you can't put, I don't know what neighborhood it is. We're in Austin, let's say Westlake. Westlake is a prominent neighborhood. Let's say there's a lot of people in Westlake can afford an electric vehicle, and they all go out of the store and buy an electric vehicle. Then they all go home at the same time, they all charge at the same time. And then all of a sudden, Austin Energy's grid just goes crazy. They can't manage all of that charging at one time. So how is the utility going to message to the auto manufacturers who are all moving to electric vehicles that I'm really sorry, our grid can't handle all of your electric vehicles. So you got to slow down. That's like Heathrow Airport telling the airlines not to schedule any more flights. The auto manufacturers are not going to accept that. So we're now starting to see auto manufacturers working directly with utilities to do long-range planning for the adoption of electric vehicles. It's a really interesting conundrum if you think about it. I think the utilities are starting to wake up to this conundrum, but I think it's one we'll start to hear more about in the coming years. And again, Intel is right in the middle of it, and we're really trying hard to help slow down. And I know I'm just about out of time, and I want to close on a couple of, okay, thanks. Another interesting area that we're starting to see quite a bit of traction. And this is around, I'll call it carbon-aware compute or carbon-aware data centers. And I'm going to use another Texas story. For whatever reason, and maybe I don't know enough about all the business case why, but Texas has become the epicenter for Bitcoin mining data centers. Primarily, I think it's because our ERCOT market is structured differently than other markets, and you can take a Bitcoin mining workload and flex the workload to be able to manage your energy based on energy needs. We're currently working with some of those Bitcoin miners that are co-locating their Bitcoin mine next to renewable energy resources. There's one particular company we're working with right now that's building out a 200 megawatt solar facility in West Texas, back in the old oil fields. And that 200 megawatt solar facility is powering their Bitcoin mining data center. That Bitcoin mining data center is going to be using some software from Intel that helps them understand their carbon footprint and helps them understand current market conditions in ERCOT and run Bitcoin mining when green power is available. But what we're finding out that's really interesting, especially in this business case, is that there are, and still today, conditions in ERCOT when they make more money turn in all their power back to the grid than they do mining Bitcoins. So that also probably has to do a lot to what's happening to the price of Bitcoins. But nevertheless, it's a really interesting business model. I'm going to build a big power center. I'm going to run e-Bitcoins, and so I'm going to differentiate my Bitcoin as a green Bitcoin to, I guess, mitigate the risk of, hey, Bitcoins aren't a critical load. Why are you taking all that energy off the grid for mining Bitcoins? So it removes that obstacle for selling Bitcoins, and again, allows the technology that we're deploying there, allows this Bitcoin miner to be able to flex their load into Bitcoin. So one thing I have learned, and I know by any means an expert at Bitcoin, but I know that unlike other data centers, the workload at a Bitcoin mine can be shifted. It can actually be turned off and then turned back on. So it's not like a critical workload that you're running at a hyperscale data center where you can't turn them on and off and you need all these redundancies. At a Bitcoin mine, you can pretty much turn them off on and off anytime. And if you're in the middle of a run, you can stop and then go back and make the run without losing a lot of money. So it's a really interesting area for us at Intel because, as you might guess, we have a lot of technology and expertise in data center. But how we're applying data center technology now to solving for the grid is a really interesting mix. And believe it or not, I was just on a call yesterday with a company out in West Texas that's actually using methane gas to produce energy to run the Bitcoin mine. So that's a double dipper. So we're taking a highly volatile methane gas, which I think has 10 times the impact of carbon dioxide on the atmosphere. We're burning it, we're removing it by burning it, and we're turning it into a Bitcoin. I don't know what they're going to call that Bitcoin, to tell you the truth, but I guess all of this I'm saying is you might not think of Intel as a player. You know, we are in PCs, we're in servers, you know, we're in a lot of other technologies, but you wouldn't think of Intel as being a solution provider or even a convener of an ecosystem in this whole energy transition. But I'm here to tell you that we are. We're a big player, and you're going to hear a lot more about our investments in this space, as well as in some of the new business models that you're starting to hear about. We mentioned this earlier, the as-a-service model. We're starting to get a lot more traction there, especially with utilities that are looking to move and react quickly, but may not have a rate case or may not have the investment needed that they need for the grid. So it's another particular area that we might focus on. Anyway, I know I'm about out of time. I just want to thank you again for letting me come in and address you. The very last thing I'll say is there's a lot of good that we're going to do here. There's a lot of impacts we're going to make on not just on greenhouse gases, but also on climate adaptation. But more on top of that, this is one of the biggest commercial opportunities of our age. And I'm quoting an article from Forbes magazine that was back in July of 22. They are saying this is a $100 trillion investment opportunity, and quote unquote, the largest commercial opportunity of our age. So not only are we going to do a lot of good, we're also going to make a lot of money while we're at it. So appreciate your time, and I really do thank you.
Thank you so much, Michael.